Good morning and welcome to the 2022 Bloom Energy Investor Conference. Thank you for being with us today. I am currently standing inside Bloom Energy's Fremont, California manufacturing plant. Bloom's newest state-of-the-art 164,000 square foot manufacturing facility that will provide a gigawatt of capacity when fully utilized. Beginning at 9:30, you will have a chance to hear directly from our CEO, K.R. Schroeder, and other leaders right here on this stage as they share our vision of a decarbonized energy future and plans to execute on an aggressive multi-year growth strategy. As the energy industry transforms, Bloom Energy is well positioned to meet the moment with an unmatched ability to directly convert fuels to net zero resilient electricity and electricity into storable net zero fuels of the future. You'll notice today's theme behind me is mission decarbonization. We chose that theme because our core technology platform was invented to create fuel and oxygen from the atmosphere of Mars using solar power. Now, back here on planet Earth, we are at a pivotal moment in history with regards to climate change. The next 30 years will be marked by a massive transformation in the way we produce, transport, and consume energy. Bloom Energy is ready for this transition. We have the technology to address many of these challenges, and we are excited about the market this creates for our business. Now, before we join the live business presentation at 9:30 today, we will have an exciting technology showcase for you, where you will have a chance to learn firsthand about the unique solid oxide platform technology that underscores our power generation and hydrogen production solutions. My colleague, Scott Reynolds, is just down the street at the Bloom Energy Research and Technical Center, where he's standing by with some of Bloom's best and brightest, all of them ready to take you on a journey through a path to a decarbonized world. Welcome, Scott. How are you this morning?
I am good, my friend. We're really excited to show off some really cool technology today and the people that are making it happen. So thanks for that great introduction. I am very excited to be with you here today because one of my favorite things to do at Bloom is to show off what we do and the people that do it. So I am joined today for our first description of what a solid oxide fuel cell is. I'm joined by Hema Nguyen. Hema, thank you for being here today. So Hema, we talk a lot about a solid oxide cell. So maybe you could start by telling us, first of all, how long have you been at Bloom?
So I've actually been with Bloom for going on almost 11 years now.
11 years. And so in 11 years, you've been working on manufacturing solid oxide cells. Maybe you could start by explaining what is a solid oxide cell.
Yeah, so a cell looks exactly like this, and it's made of an electrolyte. And in-house, we print special inks for the anode and the cathode layers. And we use our simple and low-cost and effective screen printing lines to print the inks onto the cells.
So you use low-cost processes to manufacture cells. So are these cells capable of making both electricity and hydrogen?
That's right, and using the same manufacturing process on our end, it doesn't change.
Okay, so how do they make power, and then explain how do they make hydrogen? So in one direction, they make hydrogen, right? We
Yes.
put in electricity.
Yes, in charge mode, they produce fuel hydrogen.
Yeah.
In discharge mode, they turn stored energy into electricity.
So the same cell does both. And so this is a core part of our technology. So you've been here a long time. What kinds of changes have we been making to improve these cells over time?
So we've made many changes. Since our first model, we actually tripled our power output by making a few changes. We reduced the cell thickness of the cells, which gave us the ability to have more power density in each unit, and increasing our kilowatts per square footage. And looking forward into the future, we're also increasing the size of the cell to produce even more power.
So that's really cool. So in addition to making more power, we've also reduced the amount of material that we use. So that must have a really strong impact on cost.
Definitely. Cost reduction as far as material goes has been huge as far as reducing the size of the cell, the thickness of the cell, and going forward to our new product, we're also simplifying our manufacturing process and reducing some of the components that we currently use, which are quite pricey. So when you take away those components, the material costs go down, and also the manufacturing process simplifies, and so we also get cost savings there.
So that's really cool. And in addition to that, they've gotten a lot longer lived, right?
Yes, they've forgotten, they've actually increased the life cycle by 5 times since we first started. So.
Wow, that's really amazing. So
Yeah.
the core part of the technology has improved dramatically, Justin. Back to you.
Thank you, Scott and Hema, for teaching us about fuel cells. I'll tell you what, I learned a little something there that I didn't know. For the next stop on our tour, you will learn how our core solid oxide platform can generate power through our fuel flexible energy servers running on responsibly sourced natural gas, biogas, or even hydrogen, all without combustion. And it's not just on land, but on sea, as the maritime industry takes aggressive measures to decarbonize that sector. Our platform is sea-ready and capable of replacing heavy fuels as a means of propulsion and auxiliary power for ships and ports. Our third stop today will take you through the process by which Bloom readied its fuel cells for life on the high seas. And our final stop on the tour today will explore Bloom's efforts to support the growing hydrogen economy. Bloom's core solid oxide platform can produce zero carbon hydrogen from renewable electricity through the highly efficient Bloom electrolyzer. Clean hydrogen will be a critical foundation for the energy industry of the future. Scott, can you tell us more how the platform works and how it all comes together?
Happy to do it, Justin. So I'm standing behind a visual that's going to be really, really helpful for people. And the core of the visual here, you'll see this image a lot. This is the core part of the platform. We call it a module. And so whether we're making hydrogen, whether we're making power, whether we're running a microgrid, whether we're on land, at sea, this is the core module that we use that powers everything. So the great thing about this is the more of these we make, the cheaper they get. That's a big part of our strategy, is make a lot of them have the cost come down. And so what you're going to see here in a second is the first application of the module, which is making power, which is where we started as a company. And so what we're going to do is we're going to walk over to our power generation section. We're going to go through the overhead here, and we're going to do a little bit of a history lesson where we show folks where we got started, how we evolved, and to do that, I am joined by one of our amazing star engineers, Jessica Mahler. Jessica, maybe you could start by telling us how long have you been at Bloom Energy?
Hi, Scott. It's great to be here today. I've been with Bloom for 14 years now.
14 years, so you're going to hear that as a theme from us today a lot of experience at Bloom, and a lot of us have been around for a long time, and we started engineering this device quite some time ago. So why don't you explain what's behind us here?
Sure. So what's behind us is our Generation Zero product. It could make 5 kilowatts of power. It could also co-produce hydrogen. We've been working on hydrogen since the early days, but since the market wasn't ready, we focused on making power.
So this made both hydrogen and electricity.
Yep.
And I think we recirculated the hydrogen to put it in and make more electricity, right?
Yes.
But we were making hydrogen from the early days.
Correct.
And you can see here, this is the size of maybe kind of 2 refrigerators side by
Yeah,
side.
I'd say 2 refrigerators.
So
yeah.
early days, that was kind of the power density, but of course we've been innovating for a long time.
Absolutely.
So why don't you explain a little bit, maybe we can walk over here.
Let's take a look at our...
Go down a memory lane here and talk about what you have over here.
So what we have here is our Bloom 1.0 product. It could make 25 kilowatts of power.
Okay, so 5 times the increase.
5 times the increase, lower footprint.
Okay, yeah, so this looks smaller. So how did we manage to get a lot more power out in a smaller footprint?
Well, we continue to innovate on our cells and stacks. We package things more innovatively, and we improve on our power density.
Okay, so packaging and cell improvement. And Hema just talked about the cells getting better. So the cells get better, we get more power.
Yep.
And so what's the benefit of that for customers?
Well, as we continue to innovate on our cells, our costs will stay the same, and we bring cost per kilowatts down.
So more kilowatts, less cost per kilowatt.
More kilowatts, less cost per
Got
kilowatt.
it. Okay, so this is, of course, this is ancient history now.
Ancient history.
Ancient history. What do we do next?
Well, so
Keep us
next,
going.
let's keep walking. So next, this is our Bloom 2.0 module. We could produce 42.5 kilowatts of power in this particular module.
So another big jump in power output,
Yep.
another big cost down because of the power improvement.
Yep, utilizing all very similar components and continuing to improve on our cell and stack technology.
And so this one's still, now this one's ancient history.
Also ancient history.
Okay, so let's keep going. Let's walk over here. And let's talk about this unit. So this is the unit that's most of the revenue today. So tell us what this is here behind us.
So what we're looking at here is our Bloom 5.0 energy server. Each one of these modules can produce 50 kilowatts of power.
50 kilowatts. So now we're at a 10x improvement
Yes.
from the early days.
Yep.
And one of these modules is kind of the same size, so huge power density improvements.
Power density improvements, and then continuing to use a lot of the same system architecture and components, bringing cost per kilowatt down.
So major theme for us,
Yep.
innovation, cost comes down. And this one's starting to become
Now,
an
more
old
ancient
relic as
history.
well, right? Because we made more improvements. So let's go to the last part
Let's
of
go
the
take a
tour
look
here.
at our brand new one.
Brand new one. So you've been working on this one for a while.
Yes, we have.
And so what do we have here is the final stop.
So each one of these modules can produce 75 kilowatts of power
Okay,
in
so-
the same footprint as one of the ones from our previous
So
generation.
now we're at a 15x improvement.
15x improvement and 50% improvement over our previous generation.
So we're making big leaps and bounds.
Yes, we are.
And again, you're doing that because we're
Improving on cell and stack technology using our same system architecture to bring cost per kilowatt down.
terrific. So I know in addition to doing the work on cost and power density improvement, we're adding features and functionality.
Yes, and you should go check those out next.
We're going to go check that out. So we have a video for you, Justin, to play to talk about one of our cool features, which is power independence through microgrids.
With each innovation, our economy becomes increasingly digital, and electricity is shaping the world we live in. But what if the electricity powering your business stopped? Do you wait until the electric company restores power? Or do you fire up the dirty generator that you haven't used since the last time you lost power? More than ever, electricity's critical role in manufacturing, commerce, transportation, and communication directly impacts our digital economy. Traditional electricity is supplied by above-ground and aging power lines, which are susceptible to outages. These outages are increasing in frequency, duration, and the damage they leave behind. Entire communities have been left without power following recent fires, heat waves, flooding, hurricanes, and cybersecurity breaches. The Bloom microgrid increases your access to electricity. We provide on-site power 24/7, with or without the electric grid. The Bloom microgrid is both reliable and resilient, so your business is no longer vulnerable to unexpected outages. With Bloom, the power is always on. By providing primary power at a lower, more predictable cost, your business saves money every day. And with 50% less CO2 than the US grid, it also reduces your carbon footprint. The backbone of the microgrid is the Bloom Energy Server, which converts natural gas or biogas to electricity on-site without combustion. Natural gas, supplied by the significantly more reliable underground pipeline, gives the system the ability to generate electricity through prolonged outages. The modular and redundant design of the energy server provides the fault-tolerant architecture necessary for a standalone microgrid. And if you already have a generator in place, Bloom's enhanced microgrid can parallel with your existing equipment and lengthen the runtime, while reducing emissions of your backup solution. In addition, our solution integrates with multiple technologies, including batteries and solar, to form an advanced microgrid. The reliability of this mission-critical technology has been proven through successful deployments at data centers, retailers, campuses, and manufacturing facilities around the world. So, a microgrid from Bloom Energy is not just another bright idea. It's the ultimate solution for reliable, clean, affordable power.
Welcome back from that commercial break, and thanks to Jessica Mahler for joining us this morning. As you can see, Bloom's platform can be configured as a microgrid that protects against grid outages and extreme weather disruption. Facilities operating Bloom microgrids have powered through thousands of power outages over the years. Let's check back in with Scott to see what else the Bloom platform can do.
So the platform can do a lot, Justin. And to explain one more feature, I am here with an old friend and colleague, Mike Petruka. Mike, how many years have you spent at Bloom Energy?
About 15, Scott.
15, and you spent a lot of time working on our technology.
That's right.
And one of the things that we've developed is the ability to do carbon capture. So can you talk about how our device is a natural fit for carbon capture?
Sure. So our device is amazing because it doesn't burn fossil fuels. We don't combust anything. Everything is a chemical reaction. So we don't have a lot of extra air going through our system. So the system is very clean and pure in CO2.
Okay. So the natural reaction that the system produces puts out a lot of pure CO2.
That's right.
And so if you have a stream of pure CO2, that makes it a lot easier to do whatever you want with the
clean up.
CO2.
That's right.
That's great.
That's right.
Okay, so there's not a lot of technology development here as much as maybe some downstream cleanup to purify the CO2.
Yeah, it's very similar to the systems that you saw previously.
So not a big engineering lift to do a CO2 capture system.
Exactly.
So that's just another example, Justin, of how the platform is extensible. Back to you.
It's worth noting that society still relies on fossil fuels to provide more than 80% of our global energy needs. Global energy demands are too important, complex, and large to simply cease the usage of these hydrocarbons. However, implementing technologies like carbon capture that permit their use while sequestering or utilizing the carbon emissions will play a key role in the energy transition. Carbon capture is going to take huge scale. Can we handle that, Scott?
Justin, we absolutely can handle that. So I'm here to look at one of our really cool features, which we call the Power Tower. And I'm joined today by one of my colleagues, Chad Pearson. Chad, how long have you been at Bloom Energy?
15 years, Scott.
15 years, some more experience here. So quickly, why don't you explain what's on this backdrop here for everybody and how that enables us to put a lot of power in a small square footprint?
This is what we call the Power Tower. It allows us to stack up our systems and increase our power density. This build took place in Korea, where space is at a premium.
All right, so how much power can we put in, let's just say, an acre?
Great question. So with the Power Tower, we can put 100 megawatts in about an acre of land, and a gigawatt scale plant in about 10 acres of land. That is an extremely dense footprint.
So Justin, that's just another example of how much power we can put in a small square footprint to do things like carbon capture. Back to you.
Thanks, Scott. Incredible to see the versatility of the Bloom platform. As Scott makes his way to the next stop on our tour, we turn our attention from land to the sea. With more than 90,000 ships making up the world's commercial fleet, carbon emissions from shipping alone account for approximately 3% of the world's CO2. Modernizing one of the world's oldest forms of trade with cutting-edge, clean energy technology is no small task, but that is exactly what Bloom has set out to do. Bloom Energy's fuel cell technology has excelled at powering massive loads like stadiums, manufacturers, and other large facilities on land. It makes sense that the same technology would be equally effective at sea. In 2020, Bloom and Samsung Heavy Industries announced plans to design and develop fuel cell-powered ships to realize a shared vision of clean power for the maritime industry. Since that time, we have received verification as an alternative power source for vessels as part of the American Bureau of Shipping's new technology qualification service, signaling the readiness of our fuel cells to withstand the harsh conditions at sea. And working with Chantier de l'Antique and MSC, together we launched the world's first cruise ship operating on solid oxide fuel cell technology. The future is bright as we accelerate the marine industry toward a more sustainable future. Now let's check back in with Scott to learn more about Bloom's efforts to aid marine decarbonization. Take it away, Scott.
So Justin, we're here to talk about marine. One of the really cool things that we're going to do is show you some of the testing we're doing right now to make these systems capable of running at sea. So we've got a visual for you that I think is pretty neat, which is a tilt table running here in the background, which describes some of the functionality we've used to make this capable of running at sea. And I'm joined here today by one of my longtime colleagues, Saminder Pal Singh. Saminder, how long have you been at Bloom Energy?
A little bit more than 9 years. 9 years and 3 months to
So why don't you quickly explain what's going on here with this device in the background?
Yeah, so my name is Saminder. I'm responsible for bringing Bloom's core platform to the marine world. As you can imagine, running the fuel cell on the land is slightly different than running the system on the ocean. So what we have over here is a tilt platform that replicates the environment that our system is likely to see on a ship when it's sailing on the ocean. So for the last 6 months, we have been running our hardened marinized fuel cell on the tilt tilting at 22.5 degrees constantaneously.
So how are customers reacting to seeing the capability of being able to run at sea, Saminder?
As you know, International Marine Organization has some very aggressive standards when it comes to reducing the carbon footprint. The 2030 goal is reducing the carbon intensity by 40%, and by 2050, the goal is to reach 75% carbon reduction. However, there are certain marine customers that are moving much more rapidly. An example of that is Chantier de Atlantique, which is a major shipyard that builds cruise ships. They approached us last year, towards the middle of last year, to deploy a fuel cell system on one of the ships that is going to sail later this year. So we have made tremendous progress in designing the system, testing the system, and all the units have been shipped to France. And the most exciting opportunity is what we have been hearing is there are 100 cruise ships that are in the funnel, the sales funnel for all the shipyards. That equates to about 4 gigawatt worth of power generation. That is the most exciting opportunity.
So huge opportunity in marine. We're doing the testing as we speak. Justin, back to you.
Thank you, Scott and Saminder. I'm a little seasick from all the movement on the ship there. While it's not easy to ready new technologies for marine deployment, Bloom is well on its way to decarbonizing a centuries-old maritime industry. Scott is going to continue his journey through our Research and Technical Center, making his way next to our hydrogen area. Back in 2019, Bloom announced aggressive plans to enter the commercial hydrogen market. Collaborating with industry-leading organizations, Bloom Energy has celebrated several milestones since that time in the hydrogen space. We announced the commercial availability of both hydrogen-powered energy servers and electrolyzers that produce clean hydrogen. Our 100 kilowatt energy server pilot project in the Republic of Korea commenced operations in April 2021, and our electrolyzer was successfully installed in Gumi, South Korea, and has been producing hydrogen since January of this year. Bloom and the Department of Energy's Idaho National Laboratory established an agreement to test the use of nuclear energy to create zero-carbon hydrogen using our electrolyzer. And most recently, leveraging Heliogen's concentrated solar technology and Bloom's electrolyzer, Heliogen and Bloom successfully demonstrated an economical pathway to scalable green hydrogen production. And then in December, I'm very excited to announce that in December of 2021, the Bloom electrolyzer was named Emerging Technology of the Year at the 23rd Annual S&P Global Platts Global Energy Awards. Let's check back in with Scott to learn more about the exciting work Bloom is doing in the hydrogen space. Scott, take it away.
So Justin, I'm outside. We're standing here by some really, really cool technology, and I'm joined by an old friend and colleague, Martin Perry. Martin, how long have you been at Bloom Energy?
I've been at Bloom for 19 years now.
And you've got a ton of experience working on fuel cells and electrolyzer technology.
Yes, so my 30-year career in fuel cells and electrolyzers have spanned a number of different platforms, solid oxide, PEM, alkaline, so a lot of experience getting us to this place today.
Okay, so this is an exciting place to be for both of us. Why don't you explain what's going on right here with our hydrogen fuel cell?
So just like what we do with the natural gas-based fuel cell, we're putting in a fuel, instead of natural gas, it's hydrogen. And that hydrogen goes into our system, goes through the same electrochemical reaction, and produces electrons in a very clean and sustainable way.
So is this process much different than running on, say, biogas or natural gas?
Absolutely not. In fact, the premise of our natural gas-based systems is actually the reaction is on hydrogen itself. So when we went from natural gas to hydrogen, it was a very smooth transition. We're able to take hydrogen directly into our systems with very minimal changes or impact.
So these systems right now are running on hydrogen?
They are.
Where is the hydrogen right now?
The hydrogen is in a nice big white tank down at the end of the building there, and it gets piped into here and then gets distributed to each of these power modules.
So all these cameras we have going right now, my electric car on the other side of the building, all the lighting we have inside, all that's being powered by hydrogen?
Everything that we do in this facility is being powered by hydrogen.
Okay, and what was it like to go from natural gas, biogas development to hydrogen. How long does something like that take to make it possible?
It was fairly straightforward. Again, like I said, the hydrogen was the basis of our electrochemical reaction to begin with. So for us to switch over from natural gas to hydrogen was practically seamless. We had to make a few changes in some of the hardware and some of the controls, but for the most part, the big components are exactly the same, and they're manufactured on the same production line that we do our natural gas-based systems.
Okay, that's great. So one of the big questions then is, I know we've got a tank back here.
Yes.
But we need a lot of hydrogen to power these fuel cells, so where's that hydrogen going to come from?
We have a solution for that.
We have a solution for that. So Justin, back to you. We're going to walk over to the electrolyzers, and why don't you kick us off?
Thank you, Scott. While Scott makes his way over to see the electrolyzer, it's worth noting that dozens of countries across the globe have committed to net zero emissions goals by 2050, and more than 30 countries, and counting, have hydrogen-specific strategies that are being activated. As the hydrogen economy grows, the need for hydrogen for energy storage and power generation will accelerate. For power generation, as production of hydrogen becomes ubiquitous, Bloom Energy's hydrogen fuel cells will be another option in moving to net zero emissions. Let's check back in with Scott.
So, Justin, we are now standing in front of some really, really cool technology, also something that Martin spent a lot of time working on. So, Martin, what are we looking at here?
Here we're looking at the components that make up an electrolyzer system. So we have one power module on the left, which is what we use to distribute the electricity that we need to make the hydrogen, and then the module on the right is the actual electrolyzer. And you can see it's almost identical to what we have for the hydrogen or the methane or the natural gas-based systems that we run.
Okay, so these systems right now are generating hydrogen.
They are, absolutely. We're taking power in from the grid, and we're producing hydrogen on site right here.
Okay, so same question as I asked you before. You spent a lot of time doing this.
Yes.
What does it take to go from a fuel cell that makes power to an electrolyzer that makes hydrogen?
So I'm going to sound repetitive, but it's almost the same thing. So instead of consuming fuel to produce electricity, we're using electricity to produce fuel. And the same components, the same stack components, the same cell geometry, the same manufacturing components are all used to bring this to fruition.
And so what has it been like in terms of testing and performance, and have you been happy with how these have run so far?
We've been ecstatic. So we started Bloom Energy back in the very early days doing electrolyzers. We kind of put it on the shelf for a little while, and then we brought it back in 2019. And in those 2.5 years since we've been manufacturing, it's exceeded all of our expectations. We're hitting our model targets, and the production of hydrogen we couldn't be happier with.
And so in terms of the efficiency of the fuel cell, kind of huge amounts of efficiency for the fuel cells.
Yes.
What about the efficiency of electrolyzers? How does that compare to other technologies?
So compared to our fuel cell, we're very similar. We're in that upper 50s% range for LHV conversion.
For the hydrogen fuel cell.
For the hydrogen fuel cell. And when we come over to the electrolyzer, we're by far the most efficient of all the other technologies, be it PEM, be it alkaline. So we can hit very high numbers on our electrolyzer, which makes it one of the most attractive aspects of this whole hydrogen economy emerging.
So this must be pretty exciting. Somebody who spent his whole career working on hydrogen fuel cells, this day is pretty cool, right?
Absolutely. When I started my career in fuel cells, hydrogen was the impetus for us to develop the technology. It was on a bit of a hiatus with natural gas, but that's where we needed to be at that time. And now we're back to hydrogen. So it feels like we've come full circle. Everybody's excited about the adoption of hydrogen as a future fuel, and I couldn't be happier. This is great.
Very exciting here, Justin. Back to you, my friend.
Scott, are you having fun out there? All right, sounds like Scott is enjoying himself. Scott, I look forward to getting over there and seeing it firsthand this afternoon. Thank you to Scott, thank you to the Bloom team for an informative discussion this morning about how Bloom's technology will support decarbonization efforts around the world. And thank you to those of you joining us today virtually to learn more about our growing business. In just a few moments, we will turn our attention to the main stage right here at our Fremont manufacturing plant, where Bloom leadership will kick off formal business presentations and our formal program for today's conference. You will soon hear directly from our leadership team as they articulate our vision of a decarbonized energy future and detail plans to execute an aggressive multi-year growth strategy. Thanks for joining us, and please stand by.